Figure 6.1 shows a white light incident at P on a glass prism. Only a refracted red ray PQ is shown. On a figure, draw rays to complete the path of a red ray and whole path of a violet. So first we have to complete a red ray. If we draw a normal here, normal is always perpendicular to the surface. So if this is a surface, that's how the normal will look like. Yeah. So what will happen? It will bend away from the normal. As it bend away from the normal, so because moving from glass to air, it will bend away from the normal. This will be red. How to complete the path for it's a white light, so violet is having a higher frequency. So violet bends the most and red bends the least. So what will be the change in direction for a violet? It will be more than red, and same thing, change in direction will also be more than red. So that's how we'll observe, because we'll see all the colors, but we don't have to draw path for all of them. We just have to complete a path for the red and for violet. Then there will be indigo, blue, green, yellow, orange, and red, which are in between, but we don't have to draw all of them. The one which we have to draw is a violet, and just completing a path for the red one. The next is the angle of incidence of a white light is 40. So the angle of incidence for a white light is increased to 40. So angle of incidence is 40. The refractive index is 1.52. Calculate the angle of refraction at P for a red light. So how it can be done? When you check point P, it is moving from air to glass. So this is moving from air to glass. Whenever a light travels from air to glass, so this angle of incidence is given 40 degrees. And the refractive index of the medium is given 1.52. So whenever it travels from air to glass, so we use a formula for refractive index. Refractive index is equals to sine angle I over sine angle R.
This is 0.6.
So refractive index is how much? It is 1.52. The angle of the incidence, so sine 40. Don't write only 40, write sine 40 divided by sine R. Cross multiply. So sine R will be equals to sine 40. What is sine 40?
0.
Just sine 40.
It's 0.64.
0.64. And this 1.52 is multiplied other side divided. So 0.64 divided by 1.52.
0.421.
0.421. 421. But we need R. So how to get a R? Sine move other side will become sine inverse. So R is equals to sine inverse 0.42. What's the answer?
24.8.
24.8. So you can round it off to 25. Like angle, you can write to two significant figure. That's fine. Yeah. So you can say the angle of refraction is 25. So you have to solve and show. It's of 3 mark. 1 mark is for writing a formula sine angle I over sine angle R. 1 mark is for substituting the values and showing that sine R is equivalent to what, and 1 mark is for the final answer. We need the speed of a white light at P and when it leaves at Q. Look, because at P it is in air, at point P it is in air. At point Q, it is also in air. So what is the speed of any light? It's not about white. It can be blue, green, yellow, orange, red. Any electromagnetic radiation. The refractive index of 1.52 was there. So No, we don't need a speed in a glass. We just need a speed in P and Q, which is in air. So this is also 3 into 10 power 8.
3 multiplier.
This is also 3 into 10 power 8.
2 marks.
When it's a 1 mark question, it means the direct answer is there. You don't have to show any solution. In a physics, whenever there's a 1 mark question,
Same chemistry.
so 1 mark is for, if a 1 mark question is there, it means you just have to write the answer directly. Okay. Next is question is related to a sound which we have discussed today. You can see normal air at pressure is there. Here the pressure is higher than normal, and here the pressure is lower than normal. So what we'll have if the pressure is higher than normal?
Compression.
Compression. What will the here?
Rarefaction.
Rarefaction. Because the pressure is less than the normal and pressure is higher than the normal. Okay. This is showing a variation of a pressure. What type of wave are sound? Longitudinal or transverse? So sound waves are longitudinal. On a figure 7.1, mark on axis PY a point C where there's a compression and point R where there's a rarefaction. So we just have to label, just mention, like here we can write C and here we can write R. Because the compression means the region of a high pressure, rarefaction means region of a low pressure. Then describe the motion of air particles situated in a path of a wave shown in figure 7, like how the particle will move. So air particle will move back and forth, the structure of the answer. So oscillate or vibrate back and forward, and the pressure will change. Like example, when there's a compression, the pressure will be higher. Then there's a rarefaction, the pressure will be lower. So how you structure the answer, you will mention it will vibrate back and forth. And produce series of compressions and rarefactions due to change in pressure. So whenever there is a change in pressure, it will produce a series of compressions and rarefactions.
Yes, with this works.
The next is the sound wave has a speed of 340 and the frequency is 200 hertz.
340
Calculate a distance px. First, see the figure. What is the distance px? It's a half wavelength because
Alhamdulillah.
Yes.
so from P to X, this is one complete wavelength. We need half of the wavelengths. So this is a half wavelength. So first what we do, we'll find the full wavelength and divide it by
0.87.
So how to get the full wavelength?
1.75.
So using a formula like V is the speed, F is the frequency. So we'll use a formula. V is equals to F lambda. So speed is how much? 340. Frequency is 200 multiplied by lambda. So 340 divided by 200. So when you simplify this, 1.75,
Only 7.
1.7, yeah. 1.7 is lambda. But what is px? Px is half of the wavelength. So it is 1.7 divided by 2. So what we'll get? We'll get 0.85 meter. Because how we identify, as this was given, that they ask only a distance from P to X. So these are the questions related to the topic. Like a block 4, we'll do more the next session. And we'll start the topic from topic 1. As block 3 is done, we'll again start our block 1. Any question or doubt related to the session today?
So there is
Yeah.